Okay, so in this video, we are going to look at finding the potential for a three-dimensional force and then also finding the work of this force in moving a particle from one point to another point. Okay, so they're actually giving us the potential here, which is not good because I want us to be able to actually find it. We should not be cheating. So we're going to go ahead and find it. And let's say we just agree that, yes, it's conservative. We already checked the curl and everything. So now we're trying to find the potential. So how do we do that? So the first component should be partial derivative of the potential with respect to x. So this is that. This one should be partial with respect to y, and this one would be partial with respect to z of the same function. So solving for the potential, we need to undo the derivative by partially integrating the first component with respect to x. So what is that going to be? Well, 2 and log of y are going to be numbers when you integrate with respect to x. So we keep them. And integral of x, think of x as x to the power of 1. So this is going to be 2 natural log of y. And then x is 1/2 x squared, right? So 2 and 1/2 cancel out. So we get x squared y. Now, as usual, when you integrate, you'd have to add plus c. But that c could have the other variables in it. So it could have y and z. So we possibly are missing some terms that have just y, maybe just z, or maybe a mix. Now let's undo the other derivative. So the derivative with respect to y should be equal to that. So let's undo that by integrating. And so we're integrating that now with respect to y. Okay, how do I integrate x squared divided by y with respect to y? So let me actually rewrite this as x squared times 1 over y. Okay, so it's the same thing, dividing by a number or multiplying by its reciprocal. And then plus, okay, z squared is z squared. So with respect to y. So what am I getting at here? Well, integral of 1 over y is natural log of y, and x squared we keep. So this is going to become x squared natural log of y. And integral of a number is number times the variable. So this would be z squared y. And again, we might be missing some terms that have x and z. Okay, so just eyeballing that, we already make sure that the mixed term right here, x squared natural log of y, is a match in this one, which is great. So that is correct. So this is a match. Yay. But we do have some extra term that actually had y and z. We already got that one. That's y z squared. And maybe we have another term that we are missing. Let's check that one out. So we need to now integrate the last part with respect to z. And I don't think we are going to get an extra term because this one is going to become 2y. We keep as a constant multiple. Integral of z to the power 1 is 1/2 z to the power 2. So here 2 and 1/2 cancels. And again, we could have something else that has x and y in it. Okay, so looking at the terms, we already got one mixed term matching. And now we also have this mixed term matching this one. So that's great. So these are matching. And we don't have any single terms that have only x or only y or only z. So that means our potential, we just checked, is x squared natural log of y plus yz squared. Okay, so how do we check to make sure that this is correct? You could, and I strongly recommend doing that, take the partial of this with respect to x. Do you get this part? Yes or no? If yes, you got it. Then take the partial with respect to y. Do you get this part? Yes or no? And so on this, and then with respect to z should be the last part. So always, especially on the test, do the check. But once you got it, how do you find work of this force? So why is the whole hullabaloo about the potential? What is so helpful about it? Well, there is a theorem that says that if the force is conservative, meaning that it's a gradient of something, then to find the work of this force in moving a particle from one point to another point is actually super easy. So what you do, instead of integrating, doing parameterization, substitutions, and like lengthy integral that may or may not be actually easy to compute, it turns out that the work of a conservative force does not depend on the path. What does that mean? Well, if you take 2 points, so one, let's say 7, 1, and whatever it is. So here it's -2, whatever. And the other point is some other one. The work of a conservative force does not depend on the path, which means that you can get from this point to this point by this path, for example. You can get to it by a straight line segment. You can get to it by even like this if you are really drunk and you don't know where you're going. So there could be multiple different paths, but the work is going to be the same. So such force, for example, is gravitational force. It doesn't depend on the path. But for example, force of friction or air resistance or something like that does depend on the path. But this one is conservative. So what do? All we got to do is we take the potential that we found, draw a vertical line, just like we did with regular integration, put the beginning of the path on the bottom. So this is going to be 7, 1, -2. Put the end of the path on the top, so -1 e8. And just like with the regular definite integral, in the end, what do? You substitute the limits, right? So you substitute this guy first into your function. So that's going to be whatever is f of -1, top is always first. Subtract, substitute the bottom. So substitute 7, 1, -2. And that's it. So there's no integration required. We're just substituting values. And that's so cool. So conservative forces are the best when we want to compute work. So let's see if we can put this in. So here we got our function. So x squared natural log of y plus yz squared, right? Okay, so maybe you can actually figure this out without a calculator, but I'm gonna see if I can cheat. No, I can't. Yeah, okay. I have to do it. X squared natural log of y plus yz squared. So what do I get, and why is this such an ugly one? So I'm trying to plug in there -y e8. Okay, so let's do that. So -y for x, e for y, plus y, which is e, z squared, that's 8 squared 64. Okay, so now I know why. So natural log of e is 1. Hopefully you know that, but if you do not, just use the calculator. It will tell you that's 1. -1 squared is 1. So this is 1 plus 64e. So if I'm right, then it's going to match. Yes, it's matching. So this is right. Okay, so I substituted the top. I got that. Now I'm going to substitute the bottom. So 7 for x, 1 for y, and then 1 for y here, and -2 for z. Okay, you need to know, never, ever, ever leave natural log of 1 in there, because you should know it's 0. And if you do not know, put it on the calculator. It's going to be 0. The other part is just going to be 4. So by the way, that one I could have just computed using the calculator, and that gave me a 4. But, chances are your teacher may actually not allow the calculators, then you're in trouble. Okay, so the final answer going to be, we substituted the top first, substituted the bottom, and the difference is going to be the work. So this is going to be 64e minus 3. By the way, some people get scared when they get a negative answer or 0. Don't worry about that. Work could be negative. So that's not something that you should be like freaking out about.